Okay. Just so we have it. Okay. Let me show you what I wrote. I just added this little part here. Okay, very good. So this is just the magnitude of the charge of an electron. This E here. Okay, and then H. Here's the two different ways of writing H. So everything on this piece of paper, this is the photoelectric effect. Everything that you really need to know about it. Just have that idea in your mind of how it actually works out. Okay. Any questions about this? Oh, yeah.
About the chart with all the different metals and their EV.
Okay.
This is just like a theoretical question.
Okay, yeah.
So if there was a random metal, let's say it was copper,
Okay.
but it was gold plated,
Ah.
how would it read as the gold and the copper?
So it would be some kind of modified, let me put that up here. So it would have to be some kind of modified version of it, you know, like it wouldn't just say it was gold or copper, it would be a combination of them because it depends on what the photon's actually hitting. So just thinking about it, I think if, say it was gold on the outside but copper on the inside, a photon hits the outside, it's going to be interacting with gold. So it really depends on what it's interacting with. But if it was completely mixed together, you'd have to try to figure out this probably from doing some experimenting. There's no formula to really just say what it would be. They would probably get it experimentally, like just do the experiment, figure out what the work function is, and you can get that from the stopping potential, and then come up with a new number for that. That would be a good way to do quality control, really. Say you're building something and it's a mixture of gold and copper, and you want it to be mixed up this certain exact way. Measure what the work function is of that new alloy that you have. And then later on you're producing it in a mass way. You could grab a sample from the production line, measure it, see if it's really mixed up the way you thought it was mixed up. All right, yeah, good. Ooh, got goosebumps on that. That was a good question, thank you. All right, any other questions on that? I think that's a good place to stop for the new material because I did want to leave enough time for any homework 8 questions. So any other questions on this stuff? Okay. So, and then homework 8 was all about things like thin film, interference, and diffraction gratings, double slit, and stuff like that. So any questions on chapter 17, any of the homework questions? One thing let me say about the lab. Let me load this up. Pivot. Yours will look a little bit different than this because you're not me. Let me go to a different browser. I think they haven't updated these browsers in here in a while. It's the diffraction grating experiment. Okay. Okay, activities. Preview. So here's the equation here that governs the behavior of diffraction gratings. M times the wavelength is d sine theta. But just be careful what this value of d is. This value of d is the size per slit. The value that they give here in the lab is something that is called, let's see if they're telling us what it's called. They're giving you the grading value, the lines per millimeter or something like that. So to get D and use it in the lab, you've got to take the inverse of the grading value. So if you're given something in lines per millimeter, D is the inverse of that. D has to be in millimeter per, per line. So just be careful with that. That's questions come up a couple of times. Okay. Just what D actually represents. Okay. All right, good. And then it's not so bad. Like it's a multiple choice part here, I think, that it's actually asking you about. So, for example, when it says 5 lines per millimeter, that's not D. That's the grading value. So 5 lines per millimeter, you got to invert that 1 millimeter per 5 lines, so then you know how many millimeters per 1 line. Okay.
That's the space between the two.
This is diffraction grading, so there's a whole bunch of slits, but that same idea. Yeah.
So if you had, what did you say here, 5 lines per millimeter, you're probably looking at like between 2.
That's right, exactly, yeah. 1 divided by 5, in other words. Yep, that's perfect, that's good. That's millimeter, so you might eventually have to put it into meters or something like that. But okay, that's the one thing I wanted to say about the lab. It's a pretty decent lab, other than, make sure that you know what the D stands for. Okay? So any ideas, any questions on 17 or any of the homework or anything like that? That would be homework 8. If not, that's all we have for today. All right, good. Lots of information, so I don't want to go too crazy. All right, excellent. So if you're A through L, I'll see you tomorrow. If not, work on this lab actually. Send me an email. I won't actually see you because we're not meeting Wednesday. I'll make a video. We're not meeting Monday because that's the review for the test. So I won't actually see you potentially until next Wednesday. Okay, but we'll keep in contact. Hopefully there'll be some cold, rainy days, so we are more likely to do schoolwork. I'm talking about myself. Okay, very good.